A truth table is a table that checks every possible combination of true and false values for the variables and records the true value of the expression. So the idea is quite simple. We list all possible values of P and Q and then compute what expressions become in each case. So let's start with negation here on the left. So let's look at this table. So here on this first column, we are putting the values that P can have. So P can only be either true or false. And then when we put the negation here, when P is true, the negation is false. When P is false, the negation is true. So this table sort of expresses all the possibilities of what can happen to P and consequently what can happen to not P, right? If we go to the table here on the right, we can see that now we have two propositions. So we have P and Q. So in this case, we're going to have four possibilities. You can have that P is true and Q is true. You can have that P is true and Q is false. You can also have P is false and Q is true. And finally, you can have P is false and Q is false. And then the idea is that if we want to look at an expression like P and Q, then we need to essentially fill out the table for it. So when P and Q is true, then we know that P and Q is true because both of them is true. And for all the other cases, it'll be false. So if Q is false, then it can't be that P and Q is true. If P is false, it can't be that P and Q is true. And of course, if they're both false, then it can't be that P and Q is true. Let's look at the inclusive R now. So in this case, if you have P or Q is true, you actually only need one of them to be true. So that's why you will get, if P and Q is true, both true, then you're going to get a true. If only P is true and Q is false, P or Q will still be true. If Q is true and now P is false, this will be true. And finally, when both of them are false, that's the only case where the OR will be false. Let's look at the implication we had talked about. And so this is the truth table for the implication. So we said that the implication will be false only when P is true and Q is false. And so in all the other cases, it will actually be true. And once again, I will have another video just for implication, and so we'll go more carefully on how to interpret this. And finally, here we have the biconditional. And we saw that the biconditional was true only when both P and Q had the same truth value. So when P and Q are both true, this is true. When P and Q are both false, it's also true. And now when they have different values, so P is true and Q is false, or for example, P is false and Q is true, then they will both be false.